In this video, we're going to talk about how you can graph a linear inequality in two variables. Then we're also going to talk about how you can determine whether an ordered pair is a solution of an inequality. So here we have our four symbols: greater than, less than, greater than or equal to, and less than or equal to. And I've got this in a little chart because when we have a greater than symbol, we're able to make our line shaded above. And when we have less than symbols, we're able to shade below. We also have dotted and solid. So when we have a dotted line or a dashed line, notice that we have strictly greater than and strictly less than. There are no lines underneath them. However, for our solid lines, we have the equal to bars underneath our greater than and less than signs. So I'm going to give a quick example of what it means to shade above and what it means to shade below, and what a dotted line is and what a solid line is. So on this first little graph, we're going to go ahead and do a dotted line, and I'm just going to graph an equation. So here's my equation, and I've graphed it. And so this is a dotted line. And now if I wanted to shade above, what I would do to help me determine what's above and what's below is I like to draw a little stick man kind of hiking my little line, and above would be like the sky. And so anything above him would be the sky, and that would be considered above. So here we're shading above, and we have a dotted line. So my ground would be my below. So this would be considered below, okay? So let's, on this other graph, let's go ahead and do an example here of a solid line. So I'm going to go ahead, and here I'm going to have a solid line. Notice how there's no dashes or breaks. So this is a solid line. And then if I'm looking for a below, oops, let's try that again. A below, I'm going to go ahead and I'm going to draw my little stick man walking up my line. And below would be like the ground that he's walking on. So I'm kind of coloring the mountain. Now, when it is a solid line, that means the coloring can kind of be on the line. I usually don't color my line though, but it means my line is included in my answer. Whereas for the dotted line, in this situation here, my dotted line is not part of a solution. So let's talk about how to determine whether an ordered pair is a solution to the inequality. So if I had a point that was, let's say, out here, that would not be a solution to my inequality because it's not in my colored region or on my line. If I had a point here, then that would be a solution because it's inside of my colored region. If I had a point here, it would be a solution because it's on my solid line. Now, if we go over to our above and dotted example, if I have a point right here, that would be not a solution because it is not inside of my colored shaded area, and so it would be no solution. If I had a solution right here, that would be a solution because it's inside of my colored region. But if I had a point that was right here on my line, that would be no solution. Because my line is a dotted line, that means anything on that line is not a solution. So now that you know how to determine if an ordered pair is a solution based off of where it is on your graph, let's talk about what happens when it is given to you as an actual ordered pair. So we're going to do that kind of an example as well. All right, so let's go ahead and let's move this down. So we're going to be able to tell whether the ordered pair is a solution of the inequality. And so what we're going to do here is we are simply going to plug our numbers in. So here we have an x value and we have a y value, and we're going to plug them in. And so we want to know, is that in fact going to be less than 7? So if we use our calculator and we plug in 5 times 2 plus -2, we're going to get a value of 8. So the question is 8 greater than 7? Or excuse me, is 8 less than 7? And that answer is no. And so that's going to tell us that this is no, not a solution, not a solution. Let's look at letter B. We're going to have the same thing. We're going to have our x and our y, and we're simply going to plug them in. And so we have 3 times -1 minus 4 times -1. When we plug that into our calculator, that's going to give us a value of 1. And so we want to know, is 1 greater than 6? And that answer is no. 1 is not greater than 6. So this is also not going to be a solution. Let's go ahead and check our last problem. I want you to do this one on your own. So go ahead and push pause and work out the problem. And when you're done, push play and let's see if you were correct. So we want to go ahead and take our x and y and plug them into our equation. Then we want to plug this into our calculator to see what we get. When we plug this in, we get an 8. So we want to know, is 8 greater than or equal to the number 5? And this answer is yes. So we're going to say it is a solution. That's how you can tell if a ordered pair is a solution to an inequality when you're given an ordered pair.